Hi, today we are moving on to Unit 2 in ACT Prep, which covers probability, averages, and counting techniques. A lot of these things you may have seen before, but we're going to look at some twists that sometimes can come up on standardized testing that might throw you for a little bit of a loop. So let's start with some basics. Probability is the number of favorable outcomes, things you want to happen, over the total number of outcomes. For instance, here in our first example, Billy has some jelly beans in a container. He's got 4 red, 5 green, and 3 yellow ones. What's the probability he can reach in and without looking pull out a red one? Well, my favorable would be my red. So we've got 4 of those. My total would be the total number of jelly beans including the red ones. So 4 and 5 and 3 gets me to 12. And like we've spoken about before, anytime you have standardized testing, fractions will always be reduced. So we need to make sure that we reduce that down to get our solution. Okay? Probability of an event not happening. Okay? 1 minus the probability of it actually occurring. So again, in example 2, we have the same issue here with Billy and the same number of jelly beans that he had before. Reach in and see any color other than yellow. Now there's a way you could look at this. You could either say, okay, other than yellow. Well, other than yellow would be red and green. So I could do my red plus my green out of 12. And of course, when we can reduce, we can. So it'd be 3 out of 4. Or you can look at it as 1 minus, how many yellow ones are there? Well, there's 3 out of 12. Get the 9 out of 12, and again, still reduce it. The answer is the same, it just depends on which makes more sense to you. If you're a stickler for sticking with exactly what this says, you'll go this route. If you're like, well, I'll just count up the ones that don't work and make that, you go this route. Get the same answer either way, though. If the probability of it happening is 3 out of 5, what's the probability that it doesn't? Well, if 3 out of 5 is yes, how many are left if I've used up 3? 2. Okay. And again, on a problem like this, you don't have to show the 1 minus 3/5 part. You know what that is, but it's just something to get you to think a little bit. Okay, what if multiple events are going to be happening? We're going to go ahead and we're going to multiply the probabilities together. So, Jan's flipping a fair coin and rolling a number cube with labels 1 through 6. What's the probability that the coin will land on tails? Well, let's see. What's my chance of getting heads or tails anytime I flip a coin? 1 out of 2. And whenever I roll a die, what's the chances of me rolling a particular number? 1 out of 6. And again, we're multiplying these together, not adding. So if I did this experiment 12 times, flipping a coin and rolling a die, 1 out of every 12 times I'd get tails and a 4. Now you may do it, you may get it 2 times in a row. This is what's called theoretical probability. If I were to do this thousands and thousands of times, it would approximately come back to this average of 1 out of 12. Oh, here comes Billy and his jelly beans again. Same numbers of jelly beans. See, I'd have eaten them by now, but that's a whole different story. What's the probability that Billy will reach in without looking, pull out a green jelly bean? Okay, there's our first thing, a green one. So 5 out of the total of 12. And then pull another green jelly bean without replacing the first. In other words, Billy ate the first one. Well, if he ate the first green one and we're looking to pull out another green one, how many green ones are left? 4, that's right. And if he ate one of the jelly beans out of his total, how many are left? 11. So we'll multiply across, and again, if you have one of the graphing calculators we use in class sometimes, math enter. Enter will do the trick for your reducing of a fraction. Some of you may have a fraction button. Otherwise, find small numbers that divide in. For some of you may look and say, well, I know 2 goes into both of those. And so you divide each of those by 2. Then you'd look again and say, well, they're both even. I can divide them by 2 again. And I know you're saying, but it's a standardized test. I got to be able to hurry. Hurrying is going to do nothing but get your problems wrong. If you take your time on the ones you know how to do, you're going to do well. So it gets down to 533, and that's our answer for that one. Finally, last one on this side of the page is called the fundamental counting principle. Sounds complicated. Again, we're just going to multiply the choices together. I walk into a restaurant. Sounds like all the commercials you see right now for Applebee's and Chili's and all these places. At a restaurant, you can choose from 6 different appetizers. So I'm going to get an appetizer, 4 different dinners, and 5 different desserts. How many different meals can you create? We're just going to multiply them together. There's 6 different appetizers, 4 different dinners, and 5 different desserts. And I know I'm only getting one of each, but this is letting me see if I choose one of these and one of these and one of these, I could go back to that restaurant 120 times before I would repeat the exact same choices. Dang. As we move to the back, we continue with the fundamental counting principle, talking about picking officers for a club. We have 25 members of our science club. We need a president, vice president, and treasurer, and we're assuming one person can't have more than one office. We want a democracy here. Which of the following calculations will provide the number of ways that could happen? Well, I'm going to have a president, I'm going to have a vice president, and I'm going to have a treasurer. Now, one thing we've already learned is we're multiplying with these. So we know it's not going to be D. We also know it's the different ones for each. So we know it's not going to be C. So if there's 25 options, we pick a president. That person's out of the running for vice president. So how many choices do I have left? 24. And then I choose a vice president. Now the president and vice president can't be the treasurer. So we just keep working our way down one each time. And again, unless we'll let one person be more than one office, but that's never a good idea. Okay, timing overlap, which shows up more often, and it's one of the trickier things that people just don't think about. Doug's taking 2 different meds for his cold. 1 pill every 4 hours and 1 every 6. If he just took both, how many hours will pass before he takes both again? Now you have some options here. I'll show you a couple. You can look at multiples of the 2 numbers if they're small. If I start counting by 4s and I start counting by 6s, I look for the first number in both lists that's the same. That's when this will occur again. The other way you can do it is look for the smallest number, and when I say number, I mean the numbers up here. That both numbers or both times divide into. So for instance here, does 4 even go into 2? No, it's too big. 4 goes into 4, that's good. Well, 6 doesn't go into 4, that doesn't work. Okay, and you always want to start with the smaller numbers. 4 doesn't go into 6 evenly. Does 4 go into 12? Yes. 12 divided by 4 is 3. Does 6 go into 12? Yes. 12 divided by 6 is 2. So finding the smallest number that divides into the answer, okay, with these is the best way that you can do this too. Either way works. So let's look at it that way on this next one in example 9. We're making security sweeps. One happens every 30, one happens every 45. If they just ran one together, how many minutes will pass? And again, you have your choices. If figuring out multiples of numbers quickly is not your cup of tea, is not your strength, okay, that's okay, because we can always go back and do our dividing. Well, 5 is smaller than 30. That doesn't work. 30 goes into 30, but 45 and 30, nope, doesn't work. 30 go evenly into 45? Nope. Does 30 go into 90? Yes, and if you have to go to the calculator to check this, that's not a big deal. Does 45 go into 90? Yes. Smallest number that goes into both. Always start with the smallest, because 1350 would work just like 24 would work here up above. You got to make sure it's the smallest, because this is called the least common multiple. So be careful. One last part and we're good. Okay, averages. We've been doing these forever. You add everything up and divide by number how many there are. So here we've got 124 and 145 and 113. Okay, we go ahead, we get those. Divide by 3. Be careful. If you're going on the calculator, either make sure that you add these 3 up and hit enter first and then divide by 3, or that you use parentheses, because otherwise you're going to get some ridiculous average that isn't going to make any sense. And if you get something that doesn't come out evenly, again, going to a tenth is going to be close enough on these, especially since we have multiple choice on those. And finally, and this could come in handy when you're getting to the end of a quarter and trying to figure out what you need for a grade. Marissa's taken 4 tests so far this year and gotten 89, 95, 92, 98. Pretty good. What will she have to score on her 5th and final test to average 90? Okay, I'm going to show you options again. If you want to stick it straight to how an average works, you'd say, okay, she's got 89 and 95 and 92 and 88, but we have to do this fifth test. We don't know what that is, so we make it x. And she's going to have taken 5 tests at that point. So her average equals the sum of her 5 tests divided by 5, just like we do on any average. So what I'd do here is I would add those up. And as I took a peek here, I'd say, okay, got to get rid of the fraction, so we'll times by 5. And subtract the 364 over, and we find out she needs an 86. Okay? But let's say I'm not comfortable with that. Is there another way, Mr. H? And there actually is. You kind of look at it this way. We have a goal. We know what we have so far, and that's going to equal what we need. Now, basically, we're doing the same thing, just not as much algebra to show. My goal is to, after I've taken 5 tests, to average 90. So far, I've added up the 4 scores that I have, which is 364, and that ends up being what I need. So my goal is to get 450 points. I have 364, and I still get the 86. Either way works. So thank you very much. Good luck with this. If you have any questions, let me know.